Here we write this equation in exponential form, that is y equals a times b power t, into another exponential form, that is y equals e raised to the power of k times of t minus t naught. So first we are going to consider this equation, that is y equals e raised to the power of k times of t minus t naught. Let's simplify this by first distributing this k into the terms. And so we can write this as y equals e raised to the power of kt minus k times of t naught. We can rewrite this as a product of two exponentials, that is e raised to the power of kt times e raised to the power of negative kt. And this we write according to the exponent clause, that is if we have y equals m raised to the power of a plus b, we can write this as m times of a times m power a times m power b. So I'm basically using the according to this law, and I'm going to rearrange this by writing this first, that is e raised to the power of negative k times of t naught, and e raised to the power of k times of t. Now let's compare this equation with another exponential equation, that is y equals a times of b power t. And when we compare this one with this one, we see that this expression equals this, that is a equals e raised to the power of negative k times of t naught, and then b power t equals e raised to the power of kt. So let's set up these two equations. That is, we write a equals e raised to the power of negative k times t naught, and also b power t equals e raised to the power of kt. And we consider this equation. Let's solve for k from this equation. I write this as b power t, and this equals, we can write this as e power kt as e power k raised to the power of t. And so we have b power t equals e power k power t. Now we consider raising to the power of 1 by t on both sides. That is, we do b power t, raise this to the power of 1 by t, and this one is also we have to raise it to the power of 1 by t. So I put the square bracket and raise it to the power of 1 by t. Now, according to the exponent clause, this power and this power, these two will get multiplied. That is t times of 1 by t. This equals 1. That is, we get b raised to the power of 1, which equals b. And this side we get, once again, this t and this 1 by t will get multiplied, leaving as 1. So it is e power k raised to the power of 1, which is e raised to the power of k. Now we apply natural logarithm to both sides. That is natural logarithm of v. This equals natural logarithm of e raised to the power of k. We can put this k in front according to the power rule of natural logarithms. So therefore we write natural logarithm of v, and this equals k times of natural logarithm of e. Remember that the natural logarithm of e, this equals 1. So we can just remove that from the equation. Thereby we get the value of k equals natural logarithm of b. So we write k equals natural logarithm of b. Now let's work on the other equation, that is this one. Now I apply natural logarithm to both sides, that is a natural logarithm of a, and this equals natural logarithm of e raised to the power of negative k times of t naught. Once again, this power will come in front, so we can write this as natural logarithm of a, and this equals negative k times of t naught times natural logarithm of e. We know that the natural logarithm of e is 1, so we can just remove that from the equation. And solving for k from this equation, we write k this equals natural logarithm of a divided by negative t naught, or otherwise we write down this as negative natural logarithm of a divided by t naught. Since we already know the value of k equals natural logarithm of v, we can replace it over here and solve for t naught. So I replace k equals natural logarithm of b, and this equals negative of natural logarithm of a divided by t naught. Now we can solve for t naught from this equation, first by multiplying by t naught and then dividing by natural logarithm of b. And so when we do that, we get t naught, and this equals a negative of natural logarithm of a divided by natural logarithm of b. And thus we have determined the values of k and t naught as given by these expressions. That is, k equals natural logarithm of b and t naught equals natural logarithm, that is negative of natural logarithm of a over natural logarithm of b. Now that we have determined the values of k and t naught, we can write down this exponential equation into this form of the exponential equation by replacing the values of k and t naught. So therefore we write y equals, we consider this equation, replace the values of k and t naught into this equation. So therefore this becomes e raised to the power of k is natural logarithm of b, and then multiplied with t minus t naught is negative natural logarithm of a divided by natural logarithm of b. Let's simplify this. So we get y equals e raised to the power of natural logarithm of b multiplied with t. This will be the product of two negatives is positive. T plus natural logarithm of a divided by natural logarithm of b. And so this is the equivalent exponential equation which we have written.